Introduction to Source Language Issues. In this video, we are going to see about Introduction to Source Language Issues. Introduction to Source Language Issues. Source language issues are: does the source language allow recursion? How the parameters are passed to the procedure? Does the procedure refer non-local names? How? Does the language support the memory allocation and deallocation dynamically? Does the source language allow recursion? While handling the recursive calls, there may be several instances of recursive procedures that are active simultaneously. Memory allocation must be needed to store each instance with its copy of local variables and parameters passed to that recursive procedure. But the number of active instances is determined by runtime. How the parameters are passed to the procedure. There are two methods of parameter passing: call by value, call by reference. Call by value, call by reference. The allocation strategies for each of these methods are different. Does the procedure refer non-local names? How? Any procedure has access to its local names, but a language should support the method of accessing non-local names by procedures. Does the language support the memory allocation and deallocation dynamically? The dynamic allocation and deallocation of memory brings the effective utilization of memory. There is a great effect of these source language issues on runtime environment. Hence, the storage management is very important. Overview of storage organization. In this video, we are going to see about overview of storage organization. The compiler demands for a block of memory to operating system. The size of generated code is fixed. Hence, the target code occupies the determined area of the memory. Compiler places the target code at end of the memory. The amount of memory required by the data objects is known at the time, and hence, data objects also can be placed at the statically determined area of the memory. Stack is used to manage the active procedure. Managing of active procedures means when a call occurs, then execution of activation is interrupted and information about status of the stack is saved on the stack. Heap area is the area of runtime storage in which the other information is stored. For example, memory for some data items is allocated under the program control. Memory required for these data items is obtained from this heap area. Memory for some activation is also allocated from heap area. Classification of storage allocation strategies. In this video, we are going to see about classification of storage allocation strategies. Storage allocation strategies can be classified into following ways: static allocation, stack allocation, heap allocation, static allocation. The size of data objects is known as compile time. The names of these objects are bound to storage at compile time only, and such an allocation of data objects is done by static allocation. In static allocation, the compiler can determine the amount of storage required by each data object, and therefore it becomes easy for a compiler to find the addresses of these data in the activation record. Stack allocation. Stack allocation strategy is a strategy in which the storage is organized as stack. This stack is also called control stack. Heap allocation. The heap allocation allocates the continuous block of memory when required for storage of activation records or other data object. This deallocated, that is, free space, can be reused by heap manager. The efficient heap management can be done by creating a linked list for the free blocks, and when any memory deallocated, that block of memory is appended in the linked list. Allocate the most suitable block of memory from the linked list. Accessing non-local names. In this video, we are going to see about accessing non-local names. A procedure may sometimes refer to variables which are not local to it. Such variables are called as non-local variables. For the non-local names, there are two types of rules that can be defined: static and dynamic. Static scope rule. In this type, the scope is determined by examining the program test. Pascal, C, and ADA are the languages used for the static scope rule. These languages are also called as block-structured language. Dynamic scope rule. For non-block structured languages, this dynamic scope allocation rules are used. The dynamic scope rule determines the scope of declaration of the names at runtime by considering the current activation. Lisp and Snowball are the languages which use dynamic scope rule. Methods of parameter passing. In this video, we are going to see about methods of parameter passing. There are two types of parameters: formal parameters, actual parameters. And based on these parameters, there are various parameter passing methods. The common methods are call by value, call by reference, copy restore, call by name, call by value. This is the simplest method of parameter passing. The actual parameters are evaluated and their R values are passed to caller procedure. The operation on formal parameters do not change the values of a parameter. Example, languages like C, C++ use actual parameter passing method. Call by reference. This method is also called as call by address or call by location. The L value, the address of actual parameter, is passed to the called routines activation record. Copy restore. This method is a hybrid between call by value and call by reference. This method is also known as copy in, copy out, or values result. The calling procedure calculates the value of actual parameter and it is then copied to activation record for the called procedure. During execution of called procedure, the actual parameter's value is not affected. If the actual parameter has L value, then at return, the value of formal parameter is copied to actual parameter. Call by name. This is less popular method of parameter passing. This procedure is treated like macro. The procedure body is substituted for call-in caller with actual parameters substituted for formals. The actual parameters can be surrounded by parentheses to preserve their integrity. The local names of called procedure and names of calling procedure are distinct. Concept of symbol tables. In this video, we are going to see about concept of symbol tables. Symbol table is a data structure used by compiler to keep track of semantics of variable. That means symbol table stores the information about scope and binding information about names. Symbol table is built in lexical and syntax analysis phases. I value and R value. The I and R prefixes come from left and right side assignment. Symbol table entries. The items to be stored in symbol to table are variable names, constants, procedure names, function names, literal constants and strings, compiler-generated temporaries, labels in source language. Compiler use following types of information from symbol table: data type, name, declaring procedure, offset in storage. If structure or record, then pointer to structure table. For parameters, whether parameter passing is by value or reference. Number and type of arguments passed to the function. Base address. Attributes of symbol table. Variable names. When a variable is identified, it is stored in symbol table by its name. The name must be unique. Constants. The constants are stored in symbol table. These constants can be accessed by the compiler with the help of pointers. Data types. The data types of associated variables are stored in symbol table. Compiler-generated temporaries. The intermediate code is generated by compiler. During this process, many temporaries may get generated which are stored in symbol table. Function names. The names of the functions can be stored in symbol table. Parameter names. The parameters that are passed to the function are stored in the symbol table. The information such as call by value or call by reference is also stored in table. Scope information. The scope of variable where it can be used, such type of information can be stored in symbol table. Ordered and unordered symbol table. Ordered symbol table. In ordered symbol table, the entries of variables is made in alphabetical manner. The searching of ordered symbol table can be done using linear and binary search. Advantages. Searching of particular variables is efficient. Relationship of particular variable with another can be established very easily. Disadvantages. Insertion of element in ordered list is costly if there is large number of entries in symbol table. Unordered symbol table. As variable is encountered, then its entry is made in symbol table. These entries are not in sorted manner. Each time, before inserting any variable in the symbol table, a lookup is made to check whether it is already present in the symbol table or not. Advantages. Insertion of variable in symbol table is very efficient. Disadvantages. Searching must be done using linear search. For large table size, this method turns to be inefficient because before insertion, a lookup is made. Approaches for storage allocation. In this video, we are going to see about approaches for storage allocation. Approaches for storage allocation. There are two approaches used to allocate data: explicit allocation, implicit allocation. Explicit allocation. Explicit allocation is the kind of memory allocation that can be done with the help of some procedures. Example, in Pascal, the memory allocation is done using new function and deallocation is done using dispose. Implicit allocation. Implicit allocation is a kind of allocation that can be done automatically for storing the results of expression evaluation. Various languages that handle implicit allocation are LISP, Snowball. LISP allocates a memory for the cell of a list when cons is used. Snowball allows a string of varying length. The space required for varied length of the string is managed at runtime. This space is taken from heap memory. Garbage is a substantial amount of memory which gets allocated dynamically but is unreachable memory. If this memory remains unreachable, then it becomes wastage of memory. Hence, a new technique called garbage collection is introduced. Java and Lisp are those languages which perform garbage collection. Dangling reference is a kind of complication that occurs due to explicit deallocation of memory. The dangling reference is a kind of reference that gets deallocated, which is referred to techniques used in dynamic memory allocation. In this video, we are going to see about techniques used in dynamic memory allocation. There are two techniques used in dynamic memory allocation, and those are explicit allocation, implicit allocation. Explicit allocation. The explicit allocation can be done for fixed size and variable sized blocks. Explicit allocation for fixed size blocks. This is the simplest technique of explicit allocation, in which the size of the block for which memory is allocated is fixed. In this technique, a free list is used. Free list is a set of free blocks. This is observed when we want to allocate memory. If some memory is deallocated, then the free list gets appended. The blocks are linked to each other in a list structure. The memory allocation be done by pointing previous node to the newly allocated block. Memory deallocation can be done by dereferencing the previous link. The pointer which points to first block of memory is called available. This memory allocation and deallocation is done using heap memory. The explicit allocation consists of taking a block of the list, and deallocation consists of putting the block back on the list. The advantage of this technique is that there is no space overhead. Explicit allocation of variable-sized blocks. Due to frequent memory allocation and deallocation, the heap memory becomes fragmented. That means heap may consist of some blocks that are free and some that are allocated. Suppose a list of 7 blocks gets allocated and second, fourth and sixth block is deallocated, then fragmentation occurs. Thus, we get variable-sized blocks that are available free. For allocating variable-sized blocks, some strategies such as first fit, worst fit, and best fit are used. Sometimes all the free blocks are collected together to form a large free block. This ultimately avoids the problem of fragmentation. Implicit allocation. The implicit allocation is performed using user program and runtime packages. The runtime package is required to know when the storage block is not in use. There are two approaches used for implicit allocation: reference count, marking techniques. Reference count. Reference count is a special counter used during implicit memory allocation. If any block is referred by some another block, then its reference count is incremented by 1. That also means if the reference count of particular block drops down to 0, then that means that block is not referenced 1 and hence it can be deallocated. Reference counts are best used when the pointers between blocks never appear in cycle. Marking techniques. This is an alternative approach to determine whether the block is in use or not. Sometimes bitmaps are used. These pointers are then placed in the heap memory. Again, we go through heap memory and mark those blocks which are unused. There is one more technique called compaction, in which all the used blocks are moved at the one end of heap memory so that all the free blocks are available in one large free block.